This is part 2 of using the Blackboard equation editor, or the math editor as it says in the tooltip. And I thought I'd do a simple Ohm's law type problem. And this is not really to show you how to do Ohm's law. You should already know how to do that. This is about mainly how to, a way, not how to, but a way to show your work in the text editor in Blackboard. And although this problem is going to require several steps, the first one I'll do at normal speed. I am going to complete the problem, and then I'll probably speed the video up through some of the other parts, just so the video doesn't get really long and cumbersome and boring. Okay, so because it's a lot of repeat. Once you know how to use the math editor, it's just a matter of doing the work. So anyway, we've got this resistive circuit here, and there's simple 3 resistors. We have a 24-volt source, and what I'm asking for is find the current through R1. So I want to find the current flow through R1. And all I have are the resistance values and the total voltage. So the very first thing I have to find in order to start doing some of the calculations, I need voltage drops, and I need to know some other things. So I'm going to start by calculating the total resistance of this circuit. If I get the total resistance of the circuit, I can then find the total current of the circuit. And the total current will be flowing through R3. Once I have the current through R3, I can get the voltage through R3. And once I have the voltage in R3, I will know the voltage across this parallel group, and I can calculate the current through through R1. So let's get started. I'm going to start the math editor. It's again in the additional toolbar, and it's this F sub X key. So I'm going to launch that math editor, and let me just bring it down here to make it look a little bit closer to mid-screen. And the first thing I want to do is I'm going to find total current. So I'm going to put myself a note here. I'm going to put a note for the instructor to let them know what I'm doing. So find, and I'm going to say IT. So I want to find I sub T, which is total current. So let's do the calculations. So to find our IT, the first thing I have to do is find the total resistance. All right, so find IT, I need RT. I'm using the subscript again. I need RT. Now RT is going to be nothing more than the sum of R3 plus the parallel value of R1 in parallel with R4. So let's show that as the equation first. So I'm going to arrow over to make sure I'm not on that subscript and press the enter key. So I know that RT is going to be equal to R3. I'm just going to type R3 plus, now R1 and R4 are in parallel. You can use either one of the parallel equations that you want. I'm going to use product over sum. So I'm going to take my fraction, and in the numerator I'm going to say it's R1 times R4. And again, I like to use the asterisk for the multiplication symbol rather than the X, because when you're doing some problems in math, that multiplication symbol using an X could get confused with the variable X. So the asterisk is really a better choice. And then down at the bottom, I'm going to arrow down to that. It's R1 plus R4. 4. And I'm going to arrow over to the end of the equation. So I'll show the equation that I'm going to use first. Then what I'll do is I'll fill in the values. And you want to make sure you have your units shown. Always show your units. I'm going to press the enter key, and I am going to say RT, R sub T is equal to, R3 is 220 ohms, 220. Now I want the ohms character. If you look across the tabs, actually if you even look in the menus over here, you'll see some symbols that are common. But as you go across the tabs, you'll see, oh, there's an ohm symbol. So if I click on that tab, you'll look in there and say, but I don't see the ohm symbol. Well, the ohm is the Greek letter omega, and it is a capital omega. This little W is the small letter omega. I don't know if you could see it on the video, but right here in the corner, there's a little arrow. If I click on that, there's the capital Greek letters, and I can click on capital omega, and I get ohms. And then I'll space plus, and then let's put a fraction in. So we have to go back to this tab, grab the fraction tool. R1 is 6.8 kiloohms. So I'll type 6.8 K, and I need the ohms again. Now I can either go back and get the ohms character as such, or I could go in and copy the ohms character, and I'll do that next. So we'll do times R4 is 10K, so 10K, and now I'm going to take one of these and highlight it. Oops, sorry about that. Oh no. What happened to my equation editor? There we go. I'm going to highlight that. I'm going to say Control C to copy it. I'm going to click in here and say Control V to paste it. So your copy and paste tools will also work. And I like to use Control C for copy and Control V for paste. And then we got to do the sum of this. So I could literally come in here. Notice I'm having a hard time selecting this first line. What you can do, if you want to select it rather than having to type it, you can get your cursor at the end of that ohm symbol, hold the shift key down, and use the left arrow key so you could select that text. You can do it this way, or you could just click into that little square in the denominator and just type everything. I'm going to say Control C. I'm going to arrow down to the little square, Control V, and then I'm going to come in and change this multiplication symbol. I'm going to arrow to it. I'm going to press, now I'm on the left side of that, so I'm going to hit the delete key and I'm going to type plus. So there I have the equation with values in it. Then I'll continue showing my work. So I'm going to arrow over to the end. I'm going to press the enter key, and I will again say R sub T. R sub T is equal to, and then 200 ohms. I can take this 200 ohms and copy it. Control C, arrow, Control V. What I want to do is, if you take notice, I made an error in that this equal sign is in the subscript. So I'm going to come back in there and I'm going to arrow over there and I'm going to backspace over that and replace this. I'm going to say R. I'm glad I did this, by the way, so you can see how you can just replace T, and I forgot this arrow key, and then I can say equals, and that fixed it. So all I did was went back in and fixed what I did. You have to make sure when you're in the subscripts and superscripts to make sure your cursor's in the right place. And then I'm going to do this mathematics, and I can do this off on a piece of scrap paper someplace. And I'm going to say plus, and when I do that mathematics, it comes out to 4,000, and I'm going to show the comma, 4,147.61 ohms. So I don't have the ohms on the clipboard anymore. I'm going to copy it, Control C, arrow down, there. And then I'm going to press enter, and I'm going to finish this off by saying RT I'm just about ready to do it again. I'm going to arrow until I get the big cursor, equals, and my total is 4,247.61 ohms. So there's RT. I hit the enter key. Now that I have RT, and you can see I can follow this work really well. Your instructor will really appreciate if you start showing your work in a nice orderly fashion. And you can work this out on paper first and then just transfer it into the math editor. So now that I have RT, I can find total current. And that way I'll know what the current is through R1. Because, and let me put one of these in, because I forgot the arrow over, I sub t for total current is equal to the I through R3. And we know that because the current is constant or the same in the series resistors. So let's calculate IT. So IT, and actually before I do that, I'm going to give myself a little note here to the instructor, and it's I'm going to find IT. And I'm going to try to come down here and this, shift double control C. And again, you could just retype things if you find it difficult to select items. Control V, find IT. And then I'll come back here and say that I'm having a heck of a time tonight. IT is equal to, well, current is equal to, I is equal to E over R, or V over R. I'm from the old school. I like E. So it's going to be over, so I need a division. And then this guy, I want the subscript because this is going to be E total over R total. Over R total. Arrow to the big cursor. And instead of doing another line, because this is a small equation, I'm just going to space equals space, and I'm going to fill in the values. So I'll do this, and ET is 24 volts DC, and RT is 4,247.61, and we'll get in ohms. All I'm doing is copying it, Control V, arrow over, and press equals, and we'll find that IT is equal to 0.00565 amps, or 5.65 milliamps. So now I have the total current. Once I have the total current, I can calculate the voltage drop across R3. I could actually calculate the voltage drop across the 4,000 ohms also. I mean, however you want to do it. I'm doing it the long way, so let's do this. Now I'm going to say find, and I want to find the E across R3. And E is equal to I times R. So the E across R3 is going to equal the total current, but since total current is equal to the current through R3, I'm going to say it's going to be equal to the current through R3 times R3. Now I'm going to put an equal sign again. We know the current through R3 is the total current, which is 5.65 milliamps times 220 ohms. And that's going to then equal 1.13 volts DC. Now that I have that voltage, I can calculate the voltage across the parallel group of R1, R4, because it's simply going to be the total voltage minus the drop across R3. So the E, well, let's put some text in there. So I want to get rid of this. So let's find the E across R1 in parallel with. And you know, I never looked to see if there is a double bar here to let me do parallelism. I'm just going to look, right there it is, in parallel with R4. So that's what we're doing. And then arrow down. And E across R1 is what we want to do. So the E across R1 is going to equal the total E. Notice I'm always showing the equation that I'm using first. What it will do is help your instructor know that you're doing the math right, so that if you make a math error, if you show the equation, we'll be able to know that, hey, you know how to do it, you just made a calculation error, and a lot of times you'll get partial credit for that. So this is E total minus E across R3, which is then going to equal 24 volts DC minus, I'm sorry, not 24, yeah, 24 volts DC minus 1.13 volts DC, which is going to be equal to 22.87 volts DC. I now have enough information to calculate the current through R1. So the next thing I want to do is calculate current through R1. So we know that I is equal to E over R. So I through R1 going to be equal to the E across R1, over the R1, which is going to be equal to, the voltage across R1 is 22.87 volts DC, and R1 is 6.8 kilo ohms. I don't know if the ohms is still on my clipboard, so I'll just copy it again. And then when we again do the math off screen, and we get I through R1 is 3.363 milliamps. And this problem is done. I found what I was being asked to find. I will then accept this, and you'll see that it puts the work into the text box, and it's very readable. This is something your instructor can start at the top, and it tells him what you're calculating, and it shows every single step of that calculation. This is what's called showing your work. So I hope this video helped you. It takes a little time, but you'll just show so much higher level of competency, and also you'll learn more about how to set problems up and how to do more complicated type of circuits. So again, I hope this helped, and I'll see you next time. Bye.